So today I am going to discuss about infinite series. So here I am going to consider the series of infinite, that is, we are going to consider the sequence of numbers, infinite sequence of numbers. Consider infinite sequence of numbers, sequence of numbers, say un. That is, un is what? Un is equal to u naught, u1, u2, so on, un, so on. That is, it goes up to infinity. So this is the sequence of numbers. What do you mean by sequence of numbers? There must be a relation between u naught and u1. U1, yeah, then U2 and U1. That is U1 and U0, U2 and U1, then U3 and U2. There must be a relation. That is given U1, U0, U0, U1, U2. You should be able to find out U3. There must be some definite relation between these numbers. See, for example, if I say, if I consider the sequence of numbers, that is, if I say, see, one, two, three, so on, right? So if I look at these three terms, definitely I can write down the fourth term, that is four. Then I can write down the un, that is nth term. So what will be un for this? For one, two, three, so on sequence, the nth number, the nth term, I can say un will be what? It is n. So like this, say if I give you the series like this, it is there will be a relation. There will be a relation between, that is, I can easily find out its nth term un is equal to n. Right. So this sequence of numbers is called as series. Already you have studied all these types of series actually in already all the algebraic progression, geometric progression. There, what you did, you considered the series, means sequence of n numbers. If they are related, if there is a common ratio between these two, that is called as geometric progression. If there is a common difference between the numbers, it is called as arithmetic progression. Then, if the reverse is having if reverse of a number is having common ratio, then it is called as harmonic progression. So, inverse of a number, I mean. So, like this, you have already studied arithmetic progression, geometric progression, and harmonic progression. There, you have studied n, that is sum to n terms. So that also plays an important role here. So the here in this infinite series, if the function is that means if the function if the series is divergent, that is, if the series, the numbers goes on increasing, and then it will not be of any use for us. If the series is convergent, then only, that is, if it approaches to a definite value, as in if I consider n tending to infinity, then it will be a positive value for us. So this is the sequence of numbers. Right. Then, if un is a function of n defined for integral means integer values of n, then if un is a function of n defined for all integer values of n, then the expression of the form and expression of the form u1 u2 u1 plus u2 plus u3 plus so on plus un plus so on containing infinite number of terms, infinite number of terms is called as an infinite series, is called as an infinite series. And is usually denoted by and is usually denoted by sigma n from 1 to infinity un, or simply it also can be written as or simply sigma un, right? So here we call, if I consider sum of n first n terms, the sum of first n terms of the infinite series is denoted by Sn. That is, Sn is equal to sigma n from 1 to n. It is un. So what that will be? It is 1 u1 plus u2 plus u3 plus so on plus un. Right. So this is the sum to first n terms. Right. Now what we do is, now using the idea of using this sum to first n terms, we define the convergence and divergence and convergency of an infinite series, divergency an infinite series. So the series un, sigma un, is said to be convergent if limit Sn as n tending to infinity is equal to L, a finite number where L, where L is a finite number, right? Otherwise, otherwise the series is said to be divergent. That is, when it is divergent, if it does not give a unique value, if it goes to plus or minus infinity, right? Right. If Sn gives more than one value as n tending to infinity, then the series is said to be oscillatory. Right. See, example is what? See, for example, if I consider, see, Sn is equal to what? 1 plus 1 minus 1 plus 1 minus 1 plus 1. So like this, see, I'll give you the example in the next page. If I consider un like this, say un sigma un is equal to, it is say minus 1, it starts with 1, it is alternate positive and negative units, that is 1 minus 1 plus 1 minus 1 plus 1 minus 1 plus 1, so right. Then definitely Sn will be what? Sn will be equal to plus 1 if n is odd, right? See, if it is 3, 1 minus 1, so it will be 0. Plus 1 is plus, so it will be 1. If it is 5, see, 1 minus 1 becomes 0, plus 1 minus 1 becomes 0, plus 1. So again it is plus 1. So if I consider even numbers, it will be 0 always. 1 minus 1, 0, plus 1 minus 1, 0. So 0 if n is even. Thus, Sn either tends to plus 1 or minus 1 as n tending to infinity. Sorry, Sn tends to plus 1 or 0 as n tending to infinity. Therefore, sigma un is alternating series or oscillatory series. So this is how we define the nature of the infinite series. The infinite series can be convergent series if the limit Sn as n tending to infinity is a finite number, or if it is not a finite number, that is, if it is either plus infinity or minus infinity, then it is a divergent series. And if it gives more than one value, like if I consider 1 plus 1 minus 1 minus 1 plus 1 minus 1 plus 1, so on, this also is an infinite series, but it gives me two different values, either plus 1 or minus 1. So such a series is called as oscillatory series. Now we are going to find out the ways in which we can find out the nature of the series. See, for this, we are using the various results. See, in geometric series. See, for example, sum of geometric progression. Geometric progression. What is that? So A naught plus A1R plus, A naught plus, see, A plus AR plus AR squared plus so on plus AR raised to N is geometric progression, GP, right? So what is Sn of this nth term? So it is A times R raised to N minus 1 divided by R minus 1, right? When, sorry, it is 1 minus R raised to N. 1 minus R raised to N over 1 minus R, right? It is 1 minus R raised to N over 1 minus R if R is less than 1. And it will be, right? So, uh, you know that 1 minus R raised to N, I'll write it again. So, if it is A naught, AR plus AR squared plus so on plus AR raised to N is GP, the geometric progression, then S will be what? It is A times 1 minus R raised to N over 1 minus R if R is less than 1. Certainly, this will be a convergent series, right? Because if R is less than 1, R raised to N, it gives me 0. So I get, therefore, as n tending to infinity, Sn will be equal to what? A into 1 minus 0 divided by 1 minus R, right? Because if R is less than 1, R raised to n as n tending to infinity becomes 0. So this is A over 1 minus R, right? So certain things you should know. Similarly, limit, the next one is, this is the first result. The second one is, if I consider, say, uh, the series of 1 plus x by n raised to n will be equal to e raised to x, right? So this is the another result, limit as n tending to infinity. And such things you have to use. See, for example, if I come across a situation 1 plus 1 by n raised to n, that will be equal to e raised to 1. That means e. So these are few of the results we should know as n tending to infinity. The third one is what? Limit. See, I have made use of that result here. Limit, right? See, a raised to n as n tending to infinity will be 0 if a is less than 1. Strictly, modulus of A is less than 1 or is equal to infinity if A is greater than or equal to 1. Modulus of A is greater than or equal to 1. So all these results we are using in evaluating or in finding out the nature of the series. As I told you, a series can be convergent or it can be a divergent series or it can be an oscillatory series. So we are using here, your syllabus consists of only two methods. One is D'Alembert's ratio test and the other is Cauchy's root test. Right. So we are going to study D'Alembert's ratio test and Cauchy's root test in my further actually. So now I consider D'Alembert's ratio test. So, so there are various methods are there. One is the comparison test. The other is you can compare the two series. If one of the series is fixed series, that is one of the nature of one of the series is known, then I can easily find out the nature of the other series. So that is a comparison test. So many tests are there. And then one is called as P series. So that also I can write down that also here. So the fourth one I'll write here after this. We are going to study this. The fourth result will be sigma 1 over n raised to p, where n is n is an integer, is convergent if p is a positive integer. Positive, that is p is greater than 1. That is called as p series, right? If it is equal to 1 or if it is less than or equal to 1 is divergent. If p is less than 1, right? So this also where p is a positive integer. See, 1 by n is a convergent series. 1 over n squared, 1 over n cube, all these are p series with p greater than or equal to 1. It is a convergent series. Whereas sigma 1 by root n, so it will not be a convergent series. So this is called as p series. So all these series, all these results we are using in evaluating the the nature of the series. So now, as I told you, we are going to consider first D'Alembert's ratio test. Right. What it says is, let sigma un. Again, we are assuming that sigma un is a series of positive terms. So we are just considering the series of positive terms. Let limit un plus 1 over un, that is n plus first term, the ratio of n plus 1 first term over nth term, as n tending to infinity is equal to L, right? As n tending to infinity is equal to L, so finite. That is, L is finite number, finite quantity. Then sigma un converges is convergent if L is less than 1, is sigma un is divergent if L is greater than 1. The test fails. The test fails if L is equal to 1. So what is your method now? Given an infinite series, right? Un, I should find out un plus 1, that is nth term, n plus first term, then divide that by un, right? Then find out the ratio, find out the limit as n tending to infinity. That is your job. If L is less than 1, it is convergent. If L is greater than 1, the series is divergent, right? Now, I consider example. So, I first find out, see, step one is what? You have to find out the n series. See, always they do not give sigma un. They just give the infinite series first. One or two terms, two or three terms they might give. Then you have to find out the nth term, then n plus first term, find out the ratio, then find out the limit as n tending to infinity. So if the un is given directly, then there is no problem. If un is not given directly, then we have to go for we have to find out n un first, the nth term first. Then we have to find out n plus first term, find out the ratio, find out the limit, right? So now I consider the sequence. My first example again, I take it from the question bank, right? So in the question bank of module 4, the second one, it is find the nature of or test for the convergence of also is given. Find the nature of the series, the series uh, it is 3 over 4 plus 1 plus 3 squared over 4 squared plus 1 plus 3 cube over 4 cube plus 1 plus so on. Right. So this is the question from the question bank. Right. Now I have to find out the nature of the series. See here, the nth term is not given now. Therefore, now what I should do? My first attempt is what I should find out un. See, when n is 1, it is 3 over 4 plus 1. When n is 2, the second term, 3 squared over 4 squared plus 1. The third term, 3 cube over 4 cube plus 1. Like that. So nth term will be what? It is 3 raised to n over 4 raised to n plus 1. That is un. Right. So now what is un plus 1? So un plus 1 will be, therefore, I write un plus 1 here. Un plus 1 will be what? I should replace n by n plus 1. That's all I have to do. So it is 3 raised to n plus 1 divided by 4 raised to n plus 1 plus 1. So that will be my un plus 1. Now, what is un plus 1 over un? Un plus 1 over un will be equal to, what I get? Un plus 1 is 3 raised to n plus 1 over 4 raised to n plus 1 into 1 over 3 raised to n into divided by 4 raised to n plus 1, or if I take this to the numerator, this will be 3 raised to n plus 1 over 4 raised to n plus 1 into 4 raised to n plus 1 plus 1 divided by 4 raised to n plus 1 divided by 3 raised to n. So this is my un plus 1 over un. Here 3 raised to n plus 1 cancels, leaving behind 3. So this will be what? This will be equal to, therefore, now I go for the limits directly. Limit n tending to infinity un plus 1 over un will be what? It is 3 is outside. 3 or limit, I write the formula equation first. Limit as n tending to infinity, it is 3 times 4 raised to n plus 1 divided by 4 raised to n plus 1 divided by 4 raised to n plus 1 plus 1. So this will be equal to, see, from the, so this I can write as, so this again I can simplify this as limit as n tending to infinity. From the first term, I take out 4 raised to n plus 1 outside, 4 raised to n outside. So it is 3 into 4 raised to n times 1 plus 1 over 4 raised to n divided by 4 raised to n plus 1 times 1 over, it is 1 plus 1 over 4 raised to n plus 1, this one. So this will be equal to what? 3 by 4 times limit 1, say 3 by 4 times limit, because here 4 raised to n, 4 raised to n plus 1 cancels, leaving behind 4 set. So 3 by 4 times limit 1 plus 1 over 4 raised to n divided by 1 plus 1 over 4 raised to n plus 1. So as n tending to infinity. Certainly 4 raised to n as n tending to infinity gives me, it tends to infinity, so 1 by infinity. So this gives me 0. Similarly, this gives me 0. So I am getting 3 by 4, so less than 1. There the series is convergent because it is less than 1. So this is how we use D'Alembert's ratio test in evaluating the result. Right. Now I go for one more example. So the second example from the question bank is 4 into 7 into 10, the second one. So find the nature of second one is 4 into 7 into 10, so on, 3n plus 1 divided by n factorial, right? Times x raised to n, it is given as x is greater than 0, right? I have to find out the nature of this series, that is second infinite series, right? So, uh, so that will be. Now, what is the solution? Here already nth term is given. This is nothing but un. So un is what? Un is 4 into 7 into 10, so on, into 3n plus 1 divided by n factorial times it is x raised to n. Fine. X is always greater than x is greater than 0 is already given. Now what will be un plus 1 now? So un plus 1 will be what? It is 4 into 7 into 10, so on, into 3n plus 1 into, I have to replace this n by n plus 1. So what I get? It is 3n 3 times, that is the n plus 1 plus 1, that gives me the, I have to replace n by n plus 1. So divided by, instead of n, it is n plus 1 factorial into x raised to n plus 1. Right? If I simplify this, that un plus 1 will be what? 4 into 7 into 10, so on, 3n plus 1 into, see, 3n plus 3 plus 1. So 3n plus 4 divided by n plus 1 factorial into x raised to n plus 1. So therefore, now what is the next step? I got un plus 1. So un plus 1 over un. So will be equal to what? All the terms cancel. See, except the last term, 3n plus 4 over n plus 1, that cancel, that remains. All the other terms, they cancel. So I am left with what? 3n plus 4 divided by n plus 1 into x raised to n plus 1 over x raised to n. So leaving behind x. See, always x is greater than 0 is given. Now I have to find out the limits. Therefore, limit un plus 1 over un as n tending to infinity will be what? It is limit 3n plus 1 over n plus 1 as n tending to times x as n tending to infinity. So how to evaluate this? So limit as n tending to infinity, it is n times 3 plus 1 by n divided by n times 1 plus 1 by n, right, into x. So, now this will be equal to, see, 1 by n gives me 0 as n tending to infinity. These two n's, they cancel. So this will be what? It is 3 times x. Therefore, now I use x is anyway a positive term. So now, if 3x is less than 1, right, the series converges. 3x is greater than 1, the series diverges, and 3x is equal to 1, the test fails. Right, I cannot make out any conclusion out of it. This implies what? Sigma un is convergent. I write CGT, convergent, for, see, 3x is less than 1 means what? X less than 1 by 3 is divergent. I write DGT, for x greater than 1 by 3, then test fails if x is equal to 1 by 3. So this is the solution of second infinite series. Then the third one. The third one, what it says is, the third series, infinite series is square root of 1 by 2 times x plus square root of 2 by 3 times x squared plus square root of 3 by 4 times x cubed plus so on. Right. So this is the sequence is given to you. Right now, I think you can easily do it. Right. So what is the solution now? So here the solution. The solution is what? So un will be what? See, first term is under root 1 by 2x. Second term is under root 2 by 3x. Third term is under root 3 by 4 x raised to x cubed. So un will be what? Under root n over n plus 1 into x raised to n. So if un is uh, uh, root n plus 1 over n over n plus 1 x raised to n, so what will be un plus 1? So un plus 1 will be what? So under root n plus 1 over 1 greater than n plus 1, n plus 2 into x raised to n plus 1. What is un plus 1 over un? So un plus 1 over un will be equal to this by this. So what happens? So it is root of n plus 1 over n plus 2 times x raised to n plus 1 divided by root of n over n plus 1 times x raised to n. If I simplify this, what I get? So this will be equal to what? X raised to n plus 1, x raised to n. They cancel during by x in the numerator. So this will be what? Root of uh, uh, root of n plus 1 over n into this, n plus 2 into this, if I shift it, it becomes root of n plus 1 over n times x, right? So this will be equal to, therefore, limit un plus 1 over un as n tending to infinity will be equal to what? Limit as n tending to infinity root of n plus 1 into root of n plus 1. It is n plus 1 by uh, root of n into root of n into n plus 2 times x, right? So this will be equal to limit as n tending to infinity. What I should do? I should take out n outside. So n times 1 plus 1 by n, right? Divided by, here in the second term, I take n outside. So this will be equal to n squared under root, right? Into 1 plus 2 by n into x, right? So here root of n squared is n, so these two cancel. So this I can write as limit as n tending to infinity. It is 1 plus 1 by n divided by square root of 1 plus 2 by n times x. So this gives you 1 by n and 2 by n, they go to 0. So this becomes what? X. Therefore, the series is convergent for x less than 1. It can be negative number also. The series is divergent for x greater than 1. Test fails for x is equal to 1. Right? So this is the nature of the series. So these three problems were taken from the question bank. Right? Since I consider the series of positive terms, so here x always should be greater than 0. Because in D'Alembert's ratio test, we always consider the series of positive terms. Therefore, we get x to be greater than 0. Now, I go for the second test, which is Cauchy's root test, right? Which is Cauchy's root test. So, I am going to the second one, second of the test, that is Cauchy's root test, right? So in this, the what I do is, as the name itself suggests, let sigma un be a series of be a series of positive terms, right? Be a series of positive terms, right? Then I find out, let limit as n tending to infinity un raised to 1 by n, un raised to 1 by n is equal to L. What I did, I considered un, I took the nth root of un, right? Then the Cauchy's root test says the series is convergent if L is less than 1, if L is less than 1, is divergent if L is greater than 1, test fails and test fails for L is equal to 1. If test fails, we go for further tests. So anyway, that is not there in your syllabus. So we shall concentrate only on the syllabus portions, right? So now the examples from infinite series Cauchy's root test is find the nature of the series. Examples: find the nature of the following series. Hmm? So the of that, the first one is sigma. He has given n plus 1 by n raised to n squared 1 by 3 raised to n, right? N plus 1 by n raised to n squared into 1 by 3 raised to n. So this is my first series. So here, since he has given the series directly, means considering un, I just write down the un. So now solution un is what? It is n plus 1 by n raised to n squared into 1 by 3 raised to n. Right. Now, therefore, now what I should do? I should consider un raised to 1 by n. So this is equal to, so I write down that first, n plus 1 by n whole squared, whole raised to n squared into 1 by 3 raised to n raised to 1 by n. See, a raised to m raised to n is a raised to m times n. Since a raised to m raised to n is what? A raised to m times n. We get. So un, right? Un will be equal to raised to 1 by n will be what? Right? It is n plus 1 by n squared into 1 by n into 1 by 3 raised to n into 1 by n. Right? So here you can easily observe n squared, this cancels, leaving behind n in the numerator. Here n cancels. So this, therefore, un is what? Un will be equal to, I just rewrite this, un raised to 1 by n will be equal to what? I just rewrite this, n by n is 1, it is 1 plus 1 by n raised to n times 1 by 3. Therefore, limit un raised to 1 by n as n tending to infinity will be equal to 1 by 3 constant times limit 1 plus 1 by n raised to n. This is as n tending to infinity. As I told you in the at the beginning, we are making use of this 1 plus 1 by n raised to n will be equal to e. So this is e by 3. E is 2.7 something. So definitely it is less than 1. Therefore, sigma un is convergent. Right? It is a convergent series. Right? Now I go for the second one. So second one. So second one from the example. So second one is sigma. Directly they have given 1 plus 1 by root n. 1 plus 1 by root n into minus n raised to 3 by 2. Minus n raised to 3 by 2. So I have to find out nature of this series. Right. So this, right. So solution. First, what I should do? Solution. So I should first find out un. So what is un? Un is given directly 1 plus 1 by root n raised to minus n raised to 3 by 2. Right. So un is this. So what will be un raised to 1 by n? Un raised to 1 by n will be equal to, right? So 1 plus 1 by root n, right? So raised to minus n raised to 3 by 2 into 1 by n, raised to 1 by n, right? Raised to 1 by n. Therefore, un raised to 1 by n will be equal to what? It is 1 plus 1 by root n raised to minus root n. Correct? No? Minus root n. Because I can write minus n raised to 3 by 2 minus n raised to 3 by 2 into 1 by n it will be. I have to multiply. So this minus n raised to 3 by 2 is minus n into n raised to half into root n it is. N raised to half into 1 by n. So these two cancel. So you are left with root n. That's what I wrote here. So this is uh, this is minus root of n, right? So this will be equal to this will be equal to therefore limit un raised to 1 by n as n tending to infinity will be equal to what? It is limit as n tending to infinity 1 over, I can write this as 1 plus 1 by root n raised to root n. Correct? No, minus n means it will be like this. See, if n tends to infinity, root n also tends to infinity. So I can write this as limit as n tending to infinity. So root n tending to infinity, 1 over 1 plus 1 by root n divided by root n. Right. So this is nothing but 1 by e. Certainly 1 by e is less than 1 because e is 2.7 or so, so e is less than 1. Therefore, the series is convergent. Right. Then I am considering the last problem of the question bank. No? So the what it says, the third one is what? Sigma n plus 1 raised to n plus 1 raised to n into x raised to n divided by n raised to n plus 1, n raised to n plus 1. So I have to find out the nature of the series. I should apply the Cauchy's root test. So solution. What is un now? Un is n plus 1 raised to n into x raised to n over n raised to n into n. Correct? No? Or n plus 1. So n raised to n plus 1 I can say. Therefore, what is un raised to 1 by n? The nth root of un. Right? So that will be equal to what? It is, I can easily find out in the numerator it is n plus 1 into x. Right? Divided by it is n raised to n plus 1 by into 1 by n. That means what? It is n plus 1 times x divided by n raised to 1 plus 1 by n. right? 1 plus 1 by n. So here I can take out n outside. So this will be equal to what? N times 1 plus 1 by n into x divided by c. Here I can take n outside from this, right? So I can write this as what? N times 1 plus 1 by n into x divided by, this will be what? N into n raised to 1 by n. N into n raised to 1 by n as n tending to infinity. These two cancel. Okay? These two cancel. Now I have to take the limit as n tending to infinity. So, therefore, limit un raised to 1 by n as n tending to infinity will be what? Will be equal to limit n, 1 plus 1 by n into x divided by n raised to 1 by n as n tending to infinity. So here I make use of the property that this will be equal to, this goes to 0, n raised to 1 by n also is 1. So this, if I simplify this, I get the expression that is 1 over 1 into x as limit n raised to 1 by n as n tending to infinity will be equal to 1. So there you have to take log and you have to find out the answer. So this is 1. Therefore, final answer is what? X. Therefore, the series is convergent for x less than 1, divergent for x greater than 1, test fails for x is equal to 1. So thus I have solved all the problems of the convergent and divergent series. So now see, for as far as the question paper is concerned, you are left with in the questions you will be having proving j half x and j minus half x. So that will be those are all book works. So you just go through any of the fourth semester maths book. So you get the result of that. Prove that j half x is equal to square root of 2 by pi x sin x. Prove that j minus half x is equal to square root of 2 by pi x cos x. So that I leave it to you. It is a book work. So please refer to the books and get the answer. So either of these two can be asked in the exam, right? So then I am left with the Rodriguez formula. Here also only the last problem. If it is asked, the last problem is x cube plus 2x squared minus x plus 1. I have to write p naught x and means a times p naught x plus b times p1x plus c times p2x plus d times p3x. Now I have to find out the values of a, b, and a, b, c, d. So there again it is there in the fourth semester book. So if you take any of your fourth semester friends and if you contact them, certainly they'll help you in this. So the answer will be, if I give you the hint, what you have to do is, if it is asked, anyway. If it is asked, then only. Otherwise, I need not worry about that. So what you have to do is, see, uh, see what you have to do is, see, always P naught x is, see, here I can give you the values of P naught x, P1x and P2x. So P naught x will always be equal to 1. So, I'll discuss in the next video lecture. It's very simple. Only one problem is there.